Hello class, this is Mr. Lehman, and I want to talk to you today about writing formulas of ternary ionic compounds, that have these polyatomic ions in. So up to this point we've been dealing with monatomic ions. So it's a quick review. Monatomic ions are just single atoms that have lost or gained electrons and therefore have a charge. And that's because, if they gain or lose electrons, the proton number and the electron number are no longer equal, and so they have a charge. So we learned about the different families on the periodic table. The main group elements, group 1 metals like sodium will lose 1 electron and become +1 ions. Group 2 metals like magnesium will lose 2 and become +2, and then things like group 15 like phosphorus loses gains 3 electrons and becomes a -3 ion. And remember, we call them phosphide ions because we replace the ending of the name with IDE. And then sulfur gains 2 electrons to become like argon, and it gets a -2 charge. Remember, we call this the oxidation number. And then fluorine gains an electron, becomes -1, like all the other halogens do, and we call it fluoride. So phosphide, sulfide, fluoride. So that's what we did before. Now we're looking at polyatomic ions. These groups of atoms. It can be 2 atoms, it can be 10 atoms. It really depends on the group. So the group of covalently bonded atoms, typically nonmetals, but some can have metals, like permanganate has manganese and chromate has chromium. But typically it's nonmetal atoms that are sharing electrons with each other, but together as a group they have a charge. So here I have 2 examples of polyatomic ions, groups of atoms. So here we have nitrate, NO3, so a nitrogen atom linked up with 3 oxygen atoms. So 4 atoms bonded together that have 1 more electron than protons. Alright, so they have 1 more electron given a -1 charge. Here's another one, sulfate, SO4, so 5 atoms, a sulfur atom and 4 oxygen atoms. Together they have a -2 charge. They have 2 more electrons than protons. So if we take a closer look at the nitrate ion, NO3-1, so nitrogen, this isn't an exact formula here. I'm not going to detail and show double bonds or anything like that. We'll learn how to draw correct Lewis structures later in the unit. But we have nitrogen bonded sharing electrons with 3 oxygens. So we can represent it that way. Sulfate, the sulfur is the central atom. And same thing here. We're not going to go into detail. This isn't the correct structure per se for sulfate, but it gives you a rough idea of what's going on here. The sulfur's in the middle. The oxygens are bonded along the outside. And collectively as a group, no single atom has a -2 charge, but collectively as a group, there's 2 more electrons than protons. So let's establish what we know. So alkali metals, hydrogen have a +1 charge when they're happy like noble gases. Alkaline earth metals, group 2, have a +2 charge. Typically things in group 13 have a 3+ charge. Nitrogen, group 15, typically have a -3 charge. Oxygen, -2. Group 16. Group 17, the halogens have a -1 charge. So those are the monatomic ions. Those are the go-to charges. And we talked about some of these transition metals can have more than 1 charge. And so they can have more than 1 charge. We use Roman numerals to indicate what the charge of that metal is. It can be a Roman numeral 1 + 1, or Roman numeral 2 + 2, Roman numeral 3 + 3. So here we go. And then here's our ion list. This is what was in Chem Quest 6C. You have the green sheet, which same information here for the most part. There's 1 or 2 that are on the green sheet. They're on here. This is a nice way to look at the ions. It sorts them by charge, and so I like this way. So let's look at, let's see a chemical. Let's say we have iron, Roman numeral 3, and we'll look at nitrate. And we're going to compare that to iron, Roman numeral 2, nitride. So we can just read this as iron 3 nitrate. That tells me the iron has a +3 charge. And then nitrate, I look at my list. It doesn't end in IDE, so it's not nitrogen that turns into nitride. It's not nitrogen -3, but nitrate. Nitrate is right here. Nitrate is NO3 with a -1 charge. Alright, so I'm going to go ahead and write down my ions that are present. And then I got to either do the lowest common multiple method or the crisscross method. So the number of the charge of the iron tells me how many of the nitrates I need. And the number of the charge of the nitrate tells me how many iron ions I need. And so I need to have 3 nitrates. I need to have 1 iron so that the +3 of the iron is canceled out by the -3 charge of 3 nitrates. So if I only need 1 iron ion, I just write Fe. And then I write the formula, nitrogen and 3 oxygens, that makes up a nitrate, and then how many of that ion I need. I need 3 of that polyatomic ion, and so I have to include parentheses to show that I need 3 of the whole group, that whole ion. Alright, so you have to use parentheses when you need multiples of a polyatomic ion. Let's compare that to iron 2 nitride. Iron 2 is iron that has a positive 2 charge. Nitride refers to nitrogen. So remember, if we have a negatively charged ion, an anion, and it has a charge, we replace the ending of the name of the element that's the anion and replace it with IDE. So nitride, you see the IDE ending, refers to nitrogen that has a negative 3 charge. And same thing, lowest common multiple is 6. So I would need 3 iron ions to get to a plus 6 charge, and I would need 2 of my nitride ions to get to a negative 6 charge. So Fe3N2. Alright, let's do 2 more. Let's do aluminum. Chromate. So what's the formula of aluminum chromate? So aluminum is 3 plus, positive 3. How do I know that? I go back to my periodic table, and aluminum is in group 13, and it's easier for it to lose 3 electrons and become like neon than it is to gain 5 electrons and be like argon. So once it loses 3 electrons, it'll be plus 3. Chromate is right here. Chromate is Cr O4, 1 chromium with 4 oxygen atoms. Collectively, they have a negative 2 charge. So I'm going to pull that information, write down the formula for chromate. And same thing here. I want to get to a positive 6 charge, so I'll show it this way this time. So I would need 2 aluminums to get to a plus 6, and I would need 3 chromate ions to get to a minus 6. And so together they add up to 0. Just like all ionic compounds have to be neutral. So now once I figure out how many of each I need, I write the formula. How many aluminum ions did I need? I needed 1. I needed 2. How many chromates did I need? I needed 1, 2, 1, 2, 3. So I write the formula of 1 chromate, and then I put it in parentheses, and I put a 3 on the outside to show that I need 3 of that. Alright, so that's how we write formulas for ternary ionic compounds that contain these polyatomic ions. Alright, so I hope you have a good day. If you have any questions, stop by, and I'm here to help.